Hello everyone, welcome to my YouTube channel. Myself Bharat. I am studying in Sri Venkateswara College of Engineering in the Department of Computer Science. Today we discuss about the topic vectors in computer science. What is vectors? Vectors is a quantity or phenomena that has two independent properties, magnitudes and directions. The term also denotes the mathematical or geometrical representation such as quantity. Examples of vectors in nature are velocity, momentum, forces, electromagnetic fields, and weight. The types of vectors are zero vector, unit vector, co-initial vector, collinear vector, like and unlike vector, position vectors, coplanar vectors, equal vectors, etc. The characteristic features of vectors are magnitude. Vectors have a magnitude, also known as length or size. It represents the strength or intensity of the vector. In mathematical terms, it is the non-negative number associated with the vector. Arrow. Vectors are typically represented by arrows. The tail of the arrow indicates the starting point and the head of the arrow indicates the ending point. The direction of the arrow represents the direction of the vector. Now we discuss about the operations on vectors. Dot product or scalar product. The dot product of two vectors results in a scalar quantity. Geometrically, it represents the projection of one vector on another vector multiplied by the magnitude of the second vector. The dot product is helpful to calculating work done, power and projections. Next we discuss about the cross product, also known as vector product. This operation is only defined in three-dimensional space. The cross product of two vectors in 3D results in a new vector that is orthogonal perpendicular to both original vector. The magnitude of the resulting vector is related to the area of the parallelogram formed by the two original vectors. Cross products are used to find momentums, forces, and area of parallelograms. The next is addition of vectors. Vectors can be added together. Vectors addition follows the parallelogram rule or triangular rule. Subtraction. Vector can be subtracted from each other. Subtraction of vector is the same as adding its negative. Scalar multiplication. Vector can be multiplied by scalar. A scalar is a real number. Multiplying a vector by scalar changes the magnitude of the vector, but not in its direction. And next we discuss about the applications of vector. In engineering, statistics and dynamics, analyzing force action on structure like bridges, buildings, and mechanics heavily relied on vector. Vector addition equilibrium concepts help ensure these structures can withstand various loads. Controls and robotics. Vector concepts are used in design control systems for robotics and other mechanics. specifying desired positions, velocities, and trajectories often involves. And next we discuss about computer graphics and animation, 3D modeling and animation. Vectors play a fundamental role in representing position, orientation and direction of objects in 3D space. This is crucial for creating realistic graphics and animations. Computer vision, analyzing the interpretation images and videos often involves vector operations. For example, detecting motion in a scene might involve calculating the displacement vector for pixels between frames. And some other applications of vectors are video games. Realistic movements and physical simulations in video games rely on vector calculation. Machine learning. Vectors are used to represent data points. Machine learning algorithms where the direction and magnitude of data points hold important information. Cartography, map making. Vector can used to represent directions and distance on maps. These are just few examples, and vector continue to be a powerful tool across various scientific and technical disciplines.